Hello, one. Hello, all. I hope you're having a wonderful day so far. Welcome back to the stream. We're a little bit late today. I really appreciate you guys bearing with me and, being lenient here as I am in a different setting here for my grandma's funeral. It was today. It was a great service. I appreciate you guys being patient, but we are back and ready to go here. Let me pull up the chat on my phone. All right. Let's see here. How we doing tonight, everybody? Welcome back in. All right, let's see here. All right, let's get back. Ooh. Let me pull up the chat here on the old YouTubes. All right, let's go ahead and pop this out. Hello, Gina. Hello, Wing Hong. Hello, Mahan. How's it going, everybody? Appreciate you guys for joining me here. We're going to do I'd say about 45 minutes of reading today. Just another shorter one until we get back into our regular setup tomorrow. I'll be back in my regular setup and we can do a longer 2+ hour stream. I've just been really enjoying spending some time with my family here, paying respects to my grandma. It's a great service today, very, emotional, but I appreciate you guys just being patient with me and understanding as I am out of my normal environment here. Let's go ahead and load in the chat into the here. And there we go. Got the chat loaded up. All right. Have you checked the thing? No, oh, not yet, Mahan. I'll have to I'll check that out. We can sort out in like the background and add in some CSS to the live chat to get the background removed when I get back in my normal setup, so I can get something more official. I'm kind of just in this mosh podge of lap coding here, so appreciate you joining me here. Yeah, thank you, Wing Hong. Condolences. Yeah, it's a great service. It was a good time and great to see everybody. Let's go ahead and get this stream going. I appreciate you guys joining me. Thank you so much for bearing with me on the later start. We'll be back at our normal time, hopefully tomorrow in our normal setup when I go home. Let's go ahead and dive back into some Fluent Python here, where we're going to read for about 30-45 minutes. And then we'll probably have to call it there. But of course, guys, like I said, we'll do a normal one hopefully tomorrow back in our normal setup. Okay, so we finished off with this chapter here, right? Or not, we are still on chapter 2. We were on local scope, right? All right. All right, here we go. List comprehensions versus map and filter. All right. List comps versus map and filter. Okay, let's do this. Okay. List comps do everything the map and filter functions do without the contortions of the functionality challenged Python lambda. Consider example 2-3. The same list is built by a list comp and a map/filter composition. Okay, so we have the symbols, right? We have a list comp here, beyond asking, right? And we also have this, where you can build with a lambda function. Okay, so you can call lambda C, where C is greater than 127, map ord on symbols, and create a list. Okay. I used to believe that map and filter were faster than the equivalent list comps, but Alex Martelli pointed out that's not the case, at least not in the preceding examples. The O2 array sequence list comp underscore speed.py script in the Fluent Python code repository is a simple speed test comparing list comp with filter/map. I'll have more to say about map and filter in chapter 7. Now we'll turn to the use of the list comps to compute Cartesian products, a list containing tuples built from all items from two or more lists. Cartesian products, a list containing tuples built from all items from two or more lists. Huh. Okay. Cartesian products. Okay. List comps can build lists from the Cartesian product of two or more iterables. The items may take up the Cartesian product. The items that make up the Cartesian product are tuples made from items from every input iterable. What? What are anyone know what these are? Cartesian products? Anyone have a better definition? A Cartesian product is just a way of combining two sets um, by pairing every element from the first set with every element from the second set. For example, set A is 1 and 2, set B is A, B, 1A, 1B, 2A, 2B. The Cartesian product X times B. Okay. Okay, here. We'll take this. Let's do this. I'll keep the subheading actually. And we'll go here and go Cartesian products. Right? And we'll paste that in. So a way of combining two sets by pairing every element from the first set with every element from the second set. So we'll give an example here. Oop. Right. Oh, not there, not that guy. Here. Set A. Right. So you have A is equal to 1, 2. Right. Oop. And B is equal to AB, right? So then we'll say why do I keep doing that? We'll say this A times B, or AXB product. So it's A times B is equal to a set of tuples of 1A, 1B, 2A, 2B. Right, like that. Okay. The items that make up a Cartesian product are tuples made from items from every input iterable. The resulting list has a length equal to the length of the input iterables multiplied. Right? So if this has a length of 2, this has a length of 2, well, this has a length of 4. Okay, so so we'll say, we'll go here, just make a note here, I guess. Resulting, the product has a length um, of length A times length B. Right. Cool. New chats here. Let me get caught up. Appreciate you guys for joining me here. Thank you so much. What you guys studying this evening? Let me know what you guys are working on. What you guys working on this evening? Oop. The dogs are barking. Sorry, guys. Let's go ahead. There are coyotes outside. Oh, my mom saw some coyotes outside. Wing Hong says trying to start lead code, but just watching YouTube. I feel that. I definitely feel that. All right, let's keep on going here. My mom apparently let the dogs out, and there's some coyotes out there, so scary. All right. So you have some array S and some array R, right? Which has a length of 4 and a length of 3. So this has a length of 4 times 3 of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Two sets. This. Okay, gotcha. Let me go ahead on. I'll take this image as well, just for another example. I like it. Maybe those weren't deer we saw out there. Maybe it was coyotes. You know what I mean? Maybe it wasn't deer that was out there. Maybe those were coyotes.
Yeah, I think it was.
Oh boy. Why would she put them out there then?
That's not fun. Yeah. Even if it was deer, remember?
Yeah.
Deer stomp.
Yeah. All right. Let's keep it going here. Hey, how's it going? Anubhav, welcome. I appreciate you coming to this channel and to the stream. Thank you so much for leaving a comment here. What motivated you to start learning Python? Yeah, so for those that are new here, I'm 26 years old. My name is Michael. I've been teaching myself how to program and Python, and more specifically for about a little bit over half a year now. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I'm in a different setting than my normal stream. I'm just visiting my family for a funeral and a death in the family, but I'll be back in my normal setup tomorrow to continue on with our stream and our normal hours. I usually do about two and a half minimum, usually 2.5 hours stream, every single day. But just in this different setting, and my time is all kind of whacked out. So I appreciate you guys bearing with me. Tomorrow I'm heading back home, so I should be back into my normal setup tomorrow for the normal stream around 7 p.m. PST for a good 2.5 hours. So hopefully maybe we could go longer too. What motivated me though was that I am a chemist, and I just find that computer science to be really interesting. It just really fascinates me and my scientific mindset. I really think that computers are one of the greatest invention that we've ever come up with in the past. The computers and the internet in general, you probably can group them together, one and the same. Are probably some of the greatest inventions that we've ever come up with as humans. We've been able to put rockets on the moon because of them. Like it all stems from this. In all honesty, maybe so it's really quite crazy, and I want to know much more about it, and just keep on. It just really is a topic that I really have a passion for learning more about. Honestly, that's just the real answer. Wing Hong says, "Wow, I didn't know Cartesian products can be used for cards." Yeah, I think this is just an example here of where you can just make a Cartesian product of if you say, "Okay, I want all of these suits to be applied to all of these lists." Well, you just do the two lists multiplied together to create all those products. The Cartesian product of three cards and four suits makes a sequence of 12 pairings. For example, imagine you need to produce a list of t-shirts available in two colors and three sizes. Example 2-4 shows how to produce that list using a list comp. The result has 6 items. So we have colors black and white, sizes is small, medium, and large. So we create a color and size tuple for every color and colors and for every size and sizes. Oh, that's fair. That explains it. That's pretty nice. So then it creates this printout statement here. And then you could also use the four normal syntax, for color and colors, for size and sizes, print color, size and size. So this was just printing them. So example one, okay, here we go. So number one, this generates a list of tuples arranged by color and then size. So example one, a color size tuple for every color in colors and for every size in size, all encased within a list. So we'll have a list of tuples, of a length for this entire list comprehension of t-shirts will be length of 2 times 3 or of 6, which it is, as you can see, 1, 2, 3, 4, 5, and 6. And in line 2 for color and colors, right? So in line 2, note how the resulting list is arranged as if the for loops were nested in the same order as they appear in the list comp. Okay, so this is just showing you that it outputs these values in the same order, using this list comp or this double nested for loop. The white, okay. And then in line 3, example 3 says to get back items arranged by size, then color, just rearrange the for clause. Adding a line break to the list comp makes it easier to see how the results are reordered. Okay, line 3 says t-shirts equals color size for size and sizes and for color and colors. Black small, black medium, white medium. Okay, so this is doing. Okay, so if you specify the order of the for loop, you can you can highlight to do all the colors first, and then right, and then change colors to white. So this does all the blacks and then all the white colors, and then in this one, you rearrange the for loop so you prioritize the sizing, right? So you say for size, the color and size tuple order stays the same, right? So you have that, but you specify the size for sizes first, so it filters by the size, kind of. Okay. Anubhav says, I'm a CS student, and what I can say is that you have motivated me more than anyone. I like your appreciation for consistency, but also envy you can, how can a non-CS student learn faster than me? Oh my gosh, like, that's so kind. I really look at this comment. Look at this comment. I'm a CS student, and what I can say is that you have motivated me more than anyone. I like your appreciation. I appreciate your consistency, but I also envy how you can, a non-CS student, learn faster than me.
That's awesome.
I know, that's really nice. Thank you, Anubhav. Appreciate you. I appreciate you so much for joining me. And yeah, I stream every single day. At least I try my best to. Even though I'm here, attending and visiting my family for my grandma's funeral, and I'm still coming on for at least a good 45 minutes to maybe an hour, to get some streaming in here and whatnot. So I appreciate you guys for joining me here so much. Thank you guys truly for being here. All right, let's go ahead and continue on. Let me one really quickly. Hold on one second, guys. So we'll keep going here. Clear out some of these notifications, and we'll get moving here. There we go. Well, yeah, Anubhav, thank you so much for your messages. And yeah, I can honestly attribute to this learning and pace just due to the raw consistency. People really, like with you know, like I don't know, with anything. Like if you just do it every single day, like you think about your job, like it becomes after about a year or two working in your normal job, or if it's not too strenuous or whatnot, if it's like kind of like repetitive and whatnot, it really starts to become more of a second nature kind of thing. And yeah, we're learning new things, but these concepts are building on one another. So it's key. But also I think that building on one another concept is also crucial as well, because uh, I'm not letting, so much time pass in between new topic introductions and reinforcing those topics that where I'm allowing myself to forget the information. Instead, I'm coming back the next day, solidifying it, coming back the next day, solidifying it, and then moving on to the next subject. So that process of, pounding it in, pause, is really crucial, I think. Yeah, thank Wen Hong. I appreciate you. You're awesome. Okay. Um, so I'm gonna take this example here. I'll copy this here. I like this example. All right, there we go. Cool. Uh, in example 1-1 in chapter 1, I used the following expression to initialize a card deck with a list made of 52 cards, all from all 13 cards for each of the four suits, sorted by suit, then rank. So we're going to do like a list comp. We're going to self dot underscore cards is equal to a card class, right? That we're going to make with a rank and a suit for every suit in suits and for every rank in rank. So it's ordering by suit. And then going to order by rank. Initialize a card deck that's made of 52 cards, all from all 13 ranks, sorted by suit, because you have the suit for loop first. Okay, so we'll say, I'll make a note here and say, um, the order of the uh, for loops matter to determine a filtering uh, attribute where the first for the first um, list iterated over is prioritized, right? So let me see here. This is about Cartesian products. Can you help me explain it better? Sure. When computing Cartesian products of multiple lists, the order of the lists of the for loops determines which element is changed first. This affects how the pairs or tuples are generated and can be thought of as a filtering or prioritization mechanism. Perfect. Uh, we'll take it right here. Right, computing the Cartesian product of multiple lists, the order of the for loop determines which list elements change first. This affects how the pairs or tuples are generated and can be thought of as filtering or prioritization mechanism. List comps are a one-trick pony. They build lists. They generate data to generate data from other sequence types. To generate data for other sequence types, a genexp is the way to go. General expression is the way to go. The next section is a brief look at gen expressions in the context of building sequences that are not lists. Okay, generator expressions. Okay. Okay, so this is going to be lit generator. list comprehensions was a big one, a big heading. List comprehensions and generator expressions. Okay. Cartesian products. Generator expressions. If you guys want access to these notes, they're on live on my GitHub right now. So you guys can get copies of everything I have on my GitHub and you can see on my stream, as well as I have a Discord link down below where you can get access to all of my resources completely free, a roadmap of all of my learning so far for this half a year I've been teaching myself how to code. You can get everything I have used to get to this point in my Discord completely for free. Authentic for you guys. Okay, generator expressions. Let's check on the stream here. Make sure you can read the text here. There we go. We'll keep it like that. To initialize tuples, arrays, and other types of sequences, you could also start from a list comp, but a gen expression saves memory because it yields items one by one using their iterator protocol instead of building a whole list just to feed another constructor. Generator expressions use the same syntax as list comps, but are enclosed in parentheses rather than brackets. Example 2.5 shows basic usage of general expressions to build a tuple and an array. Example 2-5, initializing a tuple and an array from a generator expression. So we have some symbols, right? So we're going to create a tuple, where we're going to convert the symbol to its Unicode value. For every symbol in symbols, that creates these. A tuple of all of these values. Import array.array, all of those okay. If the generator expression is the single argument in a function call, there is no need to duplicate the enclosing parentheses. If the generator expression is the single argument, there's no need to duplicate the, okay, got you. Number 2, the array constructor takes 2 arguments, so the parentheses around the generator expression are mandatory. Okay, so the array.array takes I as its first argument. We'll explore more. The first argument of the array constructor defines the storage type used for the numbers in the array. We'll see the in arrays on page 59. Okay. So, can you give me a simple def for gen exps? Sure, a generator expression, gen exps, is generator expressions, right? Gen exps is a concise way to create an iterator without building a full list in memory. It looks like a list comp but uses parentheses instead of square brackets. This creates a generator that produces 0, 2, 4, 6, and 8 lazily one at a time instead of storing them all in a list. So with list comps, the entire loop is ran at once and a new list is produced with the results. But with gen exps, the loop yields a value upon every iteration and stores them in a tuple. You're almost there. Just a small correction. List comprehensions run the entire loop at once and produce a new list in memory. Generate expressions do not store all the results at once. Instead, they yield one value at a time on demand and don't store them in a tuple. Key difference. Print gen object, not a tuple. Okay. Then you can convert it to a tuple. Okay. So then what is the actual point of creating a gen if you can't print it without converting to a list or tuple? Is it just to serve the purpose of yielding data back without actually expressing quote unquote yield? Yeah, you got it. Okay, sweet. The main purpose of a generated expression is to yield data on demand without storing every element in memory. Essentially, an inline way of creating a generator without using yield. Okay, I get it. So it's saying um, the main purpose of a gen exp or a generated expression is to yield data on demand without storing everything in memory. So is it storing one value at a time and overriding that value in place with the next yield? Yes, exactly. The generated expression stores one value at a time as it iterates. It overwrites the previous value in memory with the next one. Think of it as like a lazy worker who only produces the next result when asked instead of preparing everything in advance. Okay, perfect. Main purpose of generated expression is to yield data on demand without storing everything in memory. No quote yield. No yield is explicitly called, but items are returned one at a time. We'll say the next value will override the current value in memory when called to do so on the next iteration. Okay, let's take that, see what it says about that. Yep, that's a solid summary. Just a small tweak for clarity. The main purpose of a generated expression is to generate values on demand. Is to yield data on demand. Is to generate data. Generate values on demand without storing them all in memory. Unlike generator functions, genexp does not unlike um, generator functions, right? No yield is explicitly called, but items are returned one at a time as needed. The next value will override the current value in memory. So each new value replaces the previous one in memory when iterated over. Cool. That sounds good. That's a good way to break that down. I'm glad we went through that. What do you guys think? Sound good? Let me go know what you guys are studying tonight. What are you guys working on? Appreciate you for joining me here. Let's go ahead and check on the stream. Make sure everything's good. All right. Appreciate you. Thank you guys so much for joining me again. I'm really sorry for the late start today to the stream. I'll be back in my normal setup tomorrow. Just went out to dinner with my extended family to catch up, and I was at a funeral service all day today. All right. Right, so here we go. If the generator expression, so I'm going to go ahead and copy this example for the book. Right on it. Right. If the generator expression is the single argument in a function call, there is no need to duplicate the enclosing parentheses. Right, and then this one, array.array, takes the single argument, so you have to duplicate the closing. Example 2-6 uses a gen expression with a Cartesian product to print out a roster of t-shirts of 2 colors and 3 sizes. In example 2-4, here the 6 items of the t-shirt is never built into memory. In contrast to example 2-64, the 6 item list is never built into memory. The generated expression feeds the for loop product, producing one at a time. If the two lists used the Cartesian product had 1,000 items each, using a generated expression would save the cost of building a list with 1,000,000 items just to feed the for loop. Using a generator expression would save the cost of building a list with 1,000,000 items, right, just to feed the for loop. Okay, so we have colors or sizes for t-shirt in. Okay, so we do an F string here. Oh, interesting that you can. So for t-shirt in this generator, so this generator is going to produce t-shirts of a color and a size for color and colors and for size and sizes. Interesting. That's really cool. So why would we ever only want one item at a time? Why wouldn't we want to produce, oh my gosh, the list? Great question. The reason we might only want one item at a time instead of producing the entire list comes down to efficiency, both in terms of memory usage and performance. Why use a generated expression instead of a list? Efficient memory avoids storing large lists. Imagine generating 1 billion numbers. If you use a list comprehension, all those numbers are stored in memory at once, which can cause high memory usage or even crashes. So a generated expression is efficient. The general expression keeps only one value in memory at a time, while the list comprehension fills up RAM. Lazy evaluation, compute it only when needed. Sometimes we don't need all the values at once. We compute them if they might never. Why compute them if they might never be used? Faster execution for streaming data. For real-time data like stock prices, a list doesn't make much sense because the data keeps changing. Instead you need a stream of values as they arrive. So like what about So the generator object itself is stored in memory. Can you index into this and pull values without having to convert to list, tuple, etc.? Nope, you cannot index into the generator object like a list or tuple because generators do not support random access. They are iterators, meaning they produce values one at a time. They do not store previous values. Okay. Dang Patrick, hey dude, how's it going? Studying for my Physics 3 exam I got on Monday, bro. I'm about to give up. Physics 3, I only had to take general physics in college, so the first and second semester of physics. Um, and even those classes, looking back in hindsight, they weren't too tough, those first general physics classes. The only thing that was tough was just wrapping your head around how to actually understand and what I really was crucial for understanding in physics was how to read those problems because they're just paragraph problems and how to extract out the variables. That's like the one of the biggest learning curves for the physics course in my opinion was I found a way to kind of hack your way through it without trying to actually deep dive into the physics was if you can kind of extract out the variables in the problem, you can, use, at least in my college, they gave us like an equation sheet. And so you could plug things in that way. And a lot of the problems were just basically, you know, mathematical problems. So it wasn't a lot of like conceptual, like written words or anything. It was mainly just like, what is the answer for this problem? And it was just a paragraph about some scenario and you had to extract out the variables. Wow, I didn't know that you can do for loops like that for color and colors for sizes and sizes equals Cartesian product. Yes, yes, exactly. Yeah, this book is really awesome. I'm really enjoying this book so far. Even honestly, even more so than the DSA and Python. It's really more of like a not dumbed down, but just it's a lot less, wordy. It's got a lot more understandable jargon. The DSA and Python book, I know that this stuff is difficult, but the author kind of purposefully uses a lot of, you know, jargon and it's just the way of his speaking is a little bit more um, difficult to follow as just a reader. This one is really, really good so far. I'm really enjoying this. I'm learning a lot about, generators and stuff. I honestly I knew what generators were, but I actually never really knew that whole memory aspect of them. So this is really cool. That's incredible. Yeah, computers. Yeah. Dink Patrick, is it waves or optics? Waves right now. Optics are coming up, I believe. Waves right now. We talked about waves quite a bit in my chemistry courses just because you have to understand the physical aspects of light and understanding waves because electrons and particles behave like waves is at least what we found out and through discovery, which was a huge discovery understanding that electrons behave like waves so you can calculate like their electron their frequency, all of that because you can calculate their frequency, wavelength, their, all that kind of jazz just based off that discovery alone. So we could apply physics into chemistry that way as well. It was a big deal. Fun fact. How do you like it so far, Dink Patrick? What kind of stuff are you learning about in waves right now? Wavelength and amplitude, frequency. What else is there? Right, because wavelength is just frequency times the speed of light, right? Or is it, and then frequency is c divided by speed of light divided by wavelength? No, I can't remember. It's been so long. Okay, okay, so I'm gonna take this example here. Let me go here and see what this looks like. Okay, I'm going to take this one then. Right, like so. Yeah, good luck being Patrick. You got it. You got it for sure. Do you have like a physics learning center? At my college, we had the graduate students. They were obligated to host office hours at the physics tutoring center. And so when I was taking physics in college, I lived in that set tutoring center. Like I swear, I was in there all day after my physics courses sometimes, practicing that homework. Okay. In this one, the generated expression yields items one by one. A list with all six t-shirt variants is never produced in this example. Chapter 17 explains how generators work in detail. Here the idea is just to show you the use of generated expressions to initialize sequences other than lists or to produce output that you don't need to keep in memory. Now we move on to other fundamental sequence types in Python. The tuple. Tuples are not just immutable lists. Okay, so we're going to go to a 2 header now and say tuples are not just immutable lists. Some introductory text about Python presents tuples as immutable lists, but that is short selling them, right? Meaning that we can't, change the order of these. We can't append and put. We can. I don't think you can. No. Yeah. Immutable. But that is short selling them. Tuples do double duty. They can be used as immutable lists and also as records with no field names. This use is sometimes overlooked. Wait, hold on. They can be used as immutable lists and also as records with no field names. This use is sometimes overlooked, so we'll start with that. Tuples as records. Right. Tuples hold records. Each item in the tuple holds the data for one field, and the position of the item gives it meaning. If you think of a tuple just as an immutable list, the quantity and the order of the items may or may not be important, depending on the context. But when using a tuple as a collection of fields, the number of items is usually fixed and their order is always important. Shows tuples as use of records. Note, example 2-7 shows tuples as used as records. Note that in every expression, sorting the tuple would destroy the information because the meaning of each field is given by its position in the tuple. Okay, so we have tuples used as records. So, lacks coordinates, this and with negative. City, year, pop. Okay, okay, gotcha. So it's just using to describe field names, basically fields without any field names. These are the values of these fields. Okay. Um, we'll say because tuples are immutable, they can serve as records where the order and value is important within function or class calls. Like fields in a function or class call without the field names. Okay. see what the almighty Oro has to say about that. Exactly. Tuples are great for representing records because they are immutable, meaning their data can't be changed once created. This makes them ideal for situations where you need a fixed structure that wants to preserve the order and integrity of the data, like fields in a function or a class call. Why tuples work well as records? Fixed structure. The tuple size and order of the values are set and cannot be altered. This makes the tuples reliable when you need to guarantee that the data structure stays the same throughout its usage. No field names. Unlike dictionaries or classes, tuples don't use any field names, so they're often used when the position of the data itself is important, rather than having descriptive keys. Like feel of immutables. But without the name, without need for name fields. Fields and if um, the order and the values matter, but without the need for name fields. But without the need for name fields like in function calls or class calls. I don't understand that passport for loop. Okay, let's look at it. So this just shows tuples of records. For passport in sorted traveler IDs, print %s %s modulo passport. Huh. Okay, let's look. So in example one, right? In example one, the latitude and longitude of Los Angeles Airport. Okay, example two, data about Tokyo. The name, year, population change. Gotcha. Traveler IDs. Okay, so we have traveler IDs, which is a couple of tuples here. And we say for passport. So this is a passport in traveler IDs sorted print quote %s % passport. As we iterate over the list of passports is bound to each tuple. Yeah, as we iterate over the list, example 4, passport is bound to each tuple, okay? The modulo formatting operator understands tuples and treats them as a separate field. Huh, what is this? I've never seen this type of loop before, or this type of print. The for loop, oh no, in line 5, the % formatting operator understands tuples and treats each item as a separate field. Okay, so the %s will populate every field where there's a percent. What does the s do? The for loop in this example for country in travel IDs print country. For country underscore, okay, so you print country, so it'll print the first value in the tuple. The for loop, how we retrieve the items of a tuple separate. This is called unpacking. We are not interested in the second item, so we assign it to a underscore, a dummy variable, right? But what is this % thing? Like, yeah, Wing Hong, for underscore inserted. I do not understand this print syntax. The syntax you're seeing is a sample of string formatting in Python, specifically old-style string formatting using the percent operator. It's used to format strings by substituting placeholders with values. Let's break it down. Percent %s placeholders. Percent %s is the string is in the string is a placeholder for a value that will be inserted into the string. The S stands for a string, but it can also be used to format other types like integers. In your case, there are two placeholders, so it's expecting two values. Percent passport, this part is using old style string formatting to insert values into a string. The right hand side passport is the value. The right hand side passport is the value that will fill the placeholders. Passport in your example seems like it might be a tuple, first value, second value. The percent %s will insert the first value into the first percent %s and the second value into the second percent %s. What error would rise if we did not pass in enough percent %s placeholders where the tuple has values? If you don't provide enough placeholders for the values in the tuple, Python will raise a type error. Okay. So I'm going to take this here. Let's go here. Let's take this guy. No, I don't like that one. That's a better one. Sorry. I don't like that one either. It's too cut off on the top. There we go. Copy image. We'll paste that there. Go to the end, go down, go in, and we'll say quote percent %s is a placeholder variable like in C. C for printf. The percent passport syntax will the percent separate fields. So it says why does it not just do print here quote percent %s slash percent %s quote comma passport? Good question. The syntax you're suggesting would not work because of how Python handles string formatting and the percent operator. In Python, when using the percent operator inside of a string, it means that you're performing string formatting. For example, However, when you do print this passport, you're not using the string format correctly. Here's what is happening. As a regular string, the %s includes literal backslash. Oh, I didn't mean to do that. Um, so let me take this, put it back. Why can't shoot. Why can't we do it like C? There we go. I see what you're asking. You're wondering why it doesn't work the same way as string formatting does, and why it doesn't just directly print the values. Is not using string formatting correctly. Instead, Python treats this as passing multiple arguments to the print function. Okay, it's a string. When using this, you're passing two separate arguments. Okay. We'll insert the values from the tuple passport and insert them into the placeholders. We'll say we can't just call, we can't use printf quote %s slash %s comma passport right, because in Python this is seen as passing in two args into the print function, into the print. Okay, I'll take that and see what it has to say about it. It's kind of like C. So exactly, you've got it. %s is a placeholder. Used in Python, old string style, like it just like in C's printf. It tells Python to expect values to be inserted in the position when the string is printed. It's commonly used for strings, but also can be used for other data types. The %passport syntax. When you use a %passport using the tuple unpacking mechanism. Percent is a tuple unpacking is tuple unpacking syntax where the values from the tuple passport are inserted into the placeholders. Why this one doesn't work? When you use the %s slash %s comma passport, Python interprets it as passing two separate arguments to the printf. When we use the first argument being the string, the second argument being the tuple passport, since printf function just prints multiple arguments separately, you get something like John and Doe and %s. This is not the same as formatting strings you're looking for. Perfect. So we can't just pass it in as a string, as like in C, because that was Python. If you separate things by commas, it just prints those separated by commas. Right, guys? What do you guys think about that? We all good on that? Check on the stream here. All right. Let's keep on going here. We'll go for a little bit longer. Appreciate you guys joining me again. I am sorry not in my normal setup as I normally am, and the stream is a little bit shorter than normal. I do like to do 2.5 hour plus streams every single day, but I am just in a different setup. I'm visiting my parents here as I'm attending a funeral for a family member. So I appreciate you guys bearing with me on this unnormal circumstances uh, or abnormal circumstances. We'll be back in our normal setup tomorrow where we'll continue on with our 2.5 hour plus long stream. So tomorrow we'll be back in our normal setup. I appreciate you guys bearing with me for these past couple days. I am kind of disappointed in myself. I did not have time to edit a video today, unfortunately. I have footage that I can edit up from the condensed versions of the stream watch alongs for the CS50X course, and my goal was to do daily uploads here on out for a little while, but unfortunately, I am not going to be able to meet that goal today. I'm already breaking the goal early, so it kind of sucks, but I just didn't have time today under these circumstances. I was helping out in part of the funeral service, and some things are just more important, family obviously, and so I just had to sometimes you have to set priorities, and some stuff does come first, unfortunately, but I we'll be back. We're back in our normal setup tomorrow, like I said, and we'll be good to go. What was I saying? I just lost my train of thought completely. What was I saying? What was I saying?
I'm not listening. I'm sorry.
Hmm. What was I saying? Ah, shoot, I can't remember. All right. All right, let's keep on trucking here. Let's finish this page, and we'll get. Yeah, let's finish this page. Okay, let's finish this page. In general, using the underscore as a dummy variable is just a convention. It's just a strange but valid variable name. However, in a match case statement, the underscore is a wildcard that matches any value but is not bound to a value. See pattern matching with sequences on page 38, and in the Python console, the result of the preceding command is assigned to underscore unless the result is none. We often think of records as data structures with field names. Chapter 5 presents two ways of creating tuples with fields, but often with names fields, right? But often there's no need to go through that trouble of creating a class just to name the fields, especially if you leverage unpacking and avoid using indexes to access the fields. In example 2-7, we assign Tokyo 203, 2003, 32 underscore 305, 0.66, and 8014 to a city, year, pop, change, area in a single statement. The percent operator assigns each item to the passport tuple. Let's go look at this example. See here. What is that? What is that saying? Hold on. We often with fields. Chapter 5 represents, but often there's no need to go through the trouble. In example 2-9, we assign this to a city in the single statement. Then the percent operator assigns each item in the passport tuple to this corresponding slot in the formatting string print argument. Those are two examples of tuple unpacking. Okay. The term tuple unpacking is widely used by Pythonistas, but iterable unpacking. Hold on. People are talking real loud. Sorry, guys. Um, the term tuple unpacking is widely used by Pythonistas, but iterable unpacking is gaining traction. as, as the title of PEP 3132, Extended Iterable Unpacking. Unpacking sequences and iterables on page 35 present a lot more about unpacking not only tuples but sequences and iterable generals in general. Now let's consider the tuple class as an immutable variant of the list class. Tuples as immutable lists, right? Right. The Python interpreter and standard library make extensive use of tuples as immutable lists, and so should you. This brings two key benefits. Clarity. When you see a tuple in code, you know its length will never change. Performance. A tuple uses less memory than a list of the same length, and it allows Python to do some optimizations. However, be aware that the immutability of a tuple only applies to the references contained in it. References in the tuple cannot be deleted or replaced, but if one of those references points to a mutable object and that object is changed, then the values of the tuples will change. The next snippet illustrates this point by creating two tuples, A and B, which are initially equal. Figure 2.4 represents the initial layout of the B tuple in memory. So here's figure 2.4. We have alpha, we have 10, alpha, and a list of 1 and 2 in this tuple, where they have references to the objects themselves. The tuple is locked, but that list is unlocked. Right, and those are all references to integers inside of that list. So it's like we have a tuple, pointer here. We have a list pointer, and then we have no, sorry, we have a tuple object, a list object, and we have which points to, which houses pointers for all these things. So we have a tuple object which contains three pointers, one that points to an int, a str, and a list, and then the list points to ints. So these all have pointers within them. Okay, so we'll say um, uh, tuples are immutable and thus cannot have thus cannot be changed. Thus its length can not be changed. Tuples also use less memory than lists of the same length. Only applies to references. However, the immutability of tuple only applies to the references contained within. Tuples house references to the objects, pointers, right? If the actual object changes any data within, this will impact the contents of the tuple to reflect said change. Oop. Yes, that's a great explanation. Tuples are immutable in the sense that you cannot modify a tuple itself. You can't add, remove, or change elements, which is why they have often preferred performance in reasons since they use less memory compared to lists. However, if elements in the tuple inside the tuple are immutable objects, if the actual objects within the tuple are mutable and change uh, okay, let's see if it please polish my explanation. The immutable of tuples applies to references it holds, meaning you cannot modify the tuple by adding, removing, or changing elements. However, tuples store references or pointers to objects rather than the actual objects themselves. If an object within a tuple is mutable, right, like a list or dictionary, its contents are modified. Those changes will be reflected when accessing the object through the tuple, as the tuple still points to the original object. That's a great def. That's exactly what I was trying to say. The Almighty Orb has spoken. All right. Let's see how long we've been streaming for. All right, my stream's cutting out quality here. It's kind of chopping out for some reason. Why is it doing that? All right. That's good. Let's see how long we've been streaming for. All right, you guys, we've been streaming for an hour and 16, 17 minutes so far. I know this is a shorter one than my typical streams. I do apologize. I'm just not in my normal setup. I was really busy day being involved in a funeral service for a family member and, spending some time with extended family. And we went out to dinner and everything. It's always just, take advantage of those opportunities you get to see your family and be with them. The code will always be there at the end of the day. Your family members sometimes won't be. So, anyways, I really appreciate you guys joining me. Truly, I'll be back in my normal setup tomorrow. We'll do a normal 2.5 hour, 3 hour stream studying, both the DSA in Python and as well as continuing on with our Fluent Python reading in chapter 2, as well as doing DSA in Python reading, and then potentially, obviously we'll do some leak code tomorrow, and then we'll dive into maybe some more project work. But then we also need to continue on and finish the last problem of Harvard CS50X Week 9 on Flask for the Week 9 problem set. So we're going to complete that as well, maybe tomorrow or probably Monday. But honestly, the quicker we can complete that, the quicker we can move on to the last week of the course, which is basically our final project. So I really appreciate you guys joining me here. Truly, you guys are awesome. I'll see you guys tomorrow, where we'll continue on with our coding learning. We're doing it every single day around 7 p.m. PST. I really appreciate you guys joining me so far. Join the Discord, link down below in the description, where you can get access to a roadmap of all my learnings from the Fluent Python book that we're reading now, access to my GitHub personal resources and notes, to DSA and Python book, Python crash course, other people's community resources that they've provided within the I joined the call here on accident. The community resources that they're providing. We have at CS50X. I provide weekly updates for all of the weeks so far, up through week 8 that we've completed, 0 through 8 for the 2025 version. I'm going to do the same with the already completed Python course that we've done so far. And then we're going to be diving into some more math courses once we complete the Harvard CS50X course. But like I said, we do these live readings, do leak code, project work, everything. I'm really dedicated to learning this and trying to make that transition into tech maybe, or wherever it might go. I really don't know. I'm just kind of rolling with the punches. I just really enjoy actually learning the material because I find it fascinating, and I think that's what's really important at the end of the day. So thank you guys truly for joining me. I'll check chat just one last time before we sign off here. See ya, Wing Hong. Thank you so much for being here. Tuple can be. Yeah, exactly. I'm learning a lot here. Tuples can contain, mutable objects, but they can also contain different types of objects, right? This tuple housed an integer pointer, it housed a list pointer, and it housed a stir pointer. The stir is iterable. You can iterate over the stir, but it is, I don't think you can modify the elements of a stir. Can you modify are stirs mutable? are immutable. It means the string is created, its contents cannot be modified. But they are iterable. Yes, strings are iterable. So you can't change the contents of the string by overriding a specific I index value of the string, but you can iterate over the strings and print out every value of the string. So you have an int, a str, and a list, which is a mutable type. So these tuples can be dynamic for housing, like they said, records or formal data points that are set in stone, like coordinates or statistics, things like that, that don't need direct explanation via like field names and stuff like class objects and everything like that. So anyways, I'll be back in my normal setup tomorrow. I really will be looking forward to joining you guys tomorrow. So please come for the normal time tomorrow. I've said that like 5 times. I said the word tomorrow like 6 times. But anyways, I'll see you guys, what do you know, tomorrow. Bye guys. How's it going?